Okay, today's lesson is from chapter 10, which is the whole concept is you guys are going to learn about multiplying fractions, whether it be by a whole number or fraction to fraction or different methods. It's all about multiplication of fractions. So we're going to be talking about Connor and Michaela. They're going to be discussing multiplication. So it applies to the standard 5 NFB4, and we're going to be talking about Michaela, who started off saying, I can represent 3 times 2/3 with 3 rectangles, each of length 2/3. So go ahead and copy down what she just did right here. This little box right here that I'm putting a red. So Michaela thinks that she can do 3 times 2/3 if she draws 3 rectangles split into 2/3. Connor said, I know that 2/3 times 3 can be thought of as 2/3 of 3. Is 3 copies of 2/3 the same as 2/3 of 3? Okay, so Kyra suggested that maybe the picture that Michaela did is not as clear, right? So what I did is I drew 3 holes, okay, 3 fraction bars representing 3 holes. Then I split it into thirds. And then because the question was asking us 3 times 2/3, I shaded 2/3 of each hole that I have here. So then that gives me how many pieces to get, how many pieces are shaded? 6, right? 6 are shaded. In Michaela's drawing, do we also have 6 shaded pieces? Yes. What's the difference between Michaela's drawing and the one that I just drew?
Michaela's drawing doesn't include the 3 other pieces, 3 extra pieces.
Right. Do we need the 3 extra pieces represented though?
Yes.
Do you?
No. Yes. Yes. Yes.
I hear yes and no. So let me hear from someone who says yes, and let me hear from someone who says no. Let's start with yes. Harshis, why do you say yes, you need the extra pieces?
3 holes, she's saying 3 holes is just 2/3. Because if you want 2/3, you have to represent the remaining 1/3 to represent 1 hole.
So you're saying that you need, in order for it to be fully represented, you need those extra pieces. Okay, let me hear from someone who says no. Ashika.
So I think no, because even if you took away those pieces, never mind. We need those.
No, go with your thought. Even if you took away those pieces.
I was going to say even if you took away those pieces, it would be the same. But then
Right, it is the same.
Yeah, it wouldn't be the same. But if those pieces weren't there, then it would look like one whole because there's only 2 pieces and both are colored.
Would it affect the answer though? No, right?
Yeah.
So whether I choose to represent it as 3 holes, having all 3 pieces, or I choose to represent it the way that Michaela did and only represent the 2/3 that I need, I'm still going to get the same answer, correct?
So does it matter?
So does it really matter? No. Maybe for some of you, you need to visually see it as 3 holes and have all pieces represented. For some of you, only having what the shaded represented is good enough, right? Either way, you still get to the same answer, right? But you have to think about what this question is asking is, when I have these 3 holes and I'm taking 2/3 of each one. The key word in when you're thinking of multiplication, you're taking 2/3 of, this key word of means what?
Subtract.
Nope.
Multiply.
Multiply. Of means to multiply, okay? Of means to multiply, and when you have of meaning multiply, and you're saying of each whole, right? And you need 2/3, so that you're taking 2/3 of each whole that you have, okay? And that's why we came up with the answer of 2, right? Okay, so the answer is 2, right? Because I have 6 pieces out of a possible, everything is split up into thirds. 6 over 3 is equal to 2 when simplified. I draw it like Michaela's picture, or could I have drawn this another way? Besides the one that Kyra said, could I have drawn it another way? How could I have drawn it? Harshit?
Instead of doing pictures, you could have did it numerically. She said
How can I draw it differently? So here we go. What if I did 2/3 of 3? What if I flipped the problem? Instead of doing 3 times 2/3, what if I did 2/3 times 3? Would I still get the same answer?
no.
Yes.
Well, let's see here. How would I draw 2/3 of 3? So I have 3, right? If I have 2/3 of 3, right? Or 3 of 2/3, how would I draw it? Richard? Huh? Yeah, same drawing. Same thing. So whether I say 3 times 2/3 or 2/3 times 3, it's the same thing. I'm still going to get the same answer of 2. What property is that? When you can flip the numbers and they'll still give you the same answer. What property am I talking about? Brian. Say it again. Commutative, correct. Are we all, guys, is that ringing a bell? Commutative property, right? When you flip it, it's still the same, right? So then if we know that 3 times 2/3 is the same as 2/3 times 3, we can apply that property of commutative property to our problem here and know that we can still get the same answer. Yeah? Okay, so we're on page 211 at the top, and we have 3 problems here. The first one is they give you both the picture and the numerical version of the problem. So we have 3/8 times 3, which is the flip of what we just did, right, in the first problem. Whether it's 3 times 3/8 or 3/8 times 3/8 should still be the same problem, knowing our commutative property. So if we have 3 wholes here, and each of them are divided up into 8 pieces each, and we're only taking 3 of them, right? So this 3 represents the 3 that are shaded, okay? So we have 3 shaded here, 3 shaded again, and then 3 shaded again here. So then when we add up all the shaded parts, how many do we get? 9 out of the possible 8, right? When we change that to its simplest form, what do we get? 1 1/8, okay? So if we had a drawing for every single problem we had, then it's easy for us to see what the answer is, right? But what if we don't have a drawing, right? Then how are you going to figure this out, okay? Well, let's do the ones with the drawings first. So let's take a look at number 2. We have 2 wholes, which are split into 6, because that's what's our denominator here. And we want 5 out of the possible 6 parts, right? So if we take 5 out of the possible 6 parts from both wholes, how many parts do we have shaded total? 10 out of our 6, which equals 1 4/6. Is that in simplest form? Which equals 1 2/3. Okay? Let's look at problem number 3. Again, we have 3 wholes here, okay? But then they divided it into, let's see here, 4, 8, 12 pieces. Why'd they do that? Why can't they just divide it into fourths? Why couldn't they just have divided into fourths? Why do you think they divided this into 12? Mark?
To make you simplify the fraction too, like simplify the drawing too.
Okay, so that you can see it in what form? That either way you could do it, whether you shaded it vertically or,
Horizontal.
well, could you do it horizontally? I mean, vertically? Could you shade it vertically to represent 3/4?
Yes, you could just simplify.
You could, right? Either way. So then they shaded 3 of the possible 4 rows with how many pieces of each? 3? 9. 9. There's 9 in here. 9, 18, and 9, 18, 27. Thank you. Out of a possible. Naomi? Okay. So out of a possible what?
36.
Well, there's how many in each? 12, right?
36.
So the total would be 36, right? But we only have how many shaded here? 9 in each. So 9, 18, 27 are shaded out of a possible 36, right? But would that give us our answer? What do we need as our answer?
We have to find 36 subtracted by 27.
Which would give us 9. 9 over,
36.
not 36, but
9.5.
fourths, right? Because everything's in fourths. So if we have 9 fourths, that would be equal to? Very good, 2 and 1/4. Okay, so we see how it's done with pictures, right? And if you guys like to see things done visually, then go ahead and do it with the pictures, right? Draw the pictures out, make your holes, divide it into the fractional parts, shade the parts that you need, add it up, and always keep your denominator the same. Well, how could you do this if you just had numbers, right? Well, let's look at the rest of the problems that we have here. Take a look at number 4. So number 4, we have the problem 1/3 times 4. So I have 4 holes, and I want 1/3 of each hole. So what I would do is I would rewrite this problem as 1/3 times 4 over 1. I'm changing my whole number into a fraction, okay? Why would I want to change my whole number into a fraction? Gia.
Because 1/3 is a fraction.
1/3 is a fraction, so it's easier for me to see it if they're both in the same form, right? So 1/3 times 4 over 1. Does that change my whole number 4 if I make it 4 over 1?
No.
It still keeps it as 4, right? It's just in fraction form now. Now what I'm going to do, and in some ways I think that multiplying fractions is easier because all you have to do is multiply across. Our last chapter, we had to find the common denominator. In multiplication, you don't have to do that, okay? So you just do 4 times 1 is,
4.
and 3 times 1 is 3. You just multiply across. Numerators with numerators, denominators with denominators. So 4/3 is equal to 1 and 1/3. And that's your answer.
If you wanted to, could you do it without the fraction?
You could do it without the denominator. Definitely, you could do that. But in terms of setting it up and being able to see visually how it works and why I'm doing what I'm doing and how I get to my answer, this is what I'm showing you guys, okay?